Hello. Let's go ahead and get started on this new unit. It's on transformations, which is basically just moving around an object in space. Today will be about translations, which are these slides. So a transformation, though, in general, is any sort of mapping or movement that changes the position, the shape, or the size of a figure. So we see here we have a domino being flipped. Again, not really changing the size of the domino at all, but it's changing its orientation, really, which is kind of like position, right? And a domino, of course, can slide, which is today's topic. We want to really break that down and see how we can do that in the plane. And then, of course, we can rotate that domino too, again, changing its position. So the original figure in a transformation is called the pre-image because it's before, and then the final figure is called the image. So you'll hear me using these words as we move on. So here's an example of what a transformation might look like. We use the arrow here to denote an action, right? A transformation. So one quadrilateral is being moved to overlay another quadrilateral, so it really is a movement. So for here, the pre-image is going to be the black one here, and the image is going to be the result. And we use these prime marks to show that it is an after, right? So E goes to E prime, F goes to F prime. So it's almost like an updated location for that point. And you can do it for each individual part too. The image of angle F is angle F prime. The side that corresponds with GH is going to be GH, but with primes, right? So it's just showing how to go from one to the other. So again, with these triangles here, we start with the one without any marks at all, and we move to the one that has the prime marks. So this is the image, right? PRT as a triangle is the pre-image, but the image is this blue one that we have here. And it looks like it got shrunk a little bit, maybe reflected somehow to get there. So the image of angle P is angle P prime, and then RT prime with two prime marks. Okay? All right, so just kind of getting the notation down a little bit. So a special type of transformation is called a rigid motion, which we've touched on before. It's a transformation that preserves distances and angle measures. Okay, so here we have a pre-image and an image, it's diamond shape. It's actually a kite. It's the term we use for it. It looks like it's a rigid motion, right? The distances, like the lengths of the sides, didn't change, and the angles seem to be preserved too. So this is indeed a rigid motion. I think it was more like you could spin it maybe 180 degrees to get there. Maybe you could reflect it. There are three rigid motions, which we're going to be talking about in the next three sections. One's a translation, and one is the reflection, and then finally is the rotation. So that's what rigid motions are. It's just one of these three things. So this next one kind of violates that, right? Those sides of that square, they got bigger, right? So this is not a rigid motion, okay? So it's got to be one of those three. Great. So here we have a diagram that shows ABC being translated. That's what the capital T stands for here, is a translation over to A prime, B prime, C prime. So a translation maps every single point, all the vertices of a figure, the same amount of distance in the same direction. So that's what those red arrows or vectors are doing, is they're taking B to B prime. They're showing, and every arrow, every red arrow or vector there is the same length and it goes in the same direction, right? So that's what a translation is. So of course it changes the position because it was slid to a new spot, but the shape and the size stay the same. So a little bit of notation here. If I say, like up here, T of triangle ABC means that we are translating triangle ABC, and it's going to equal the image, this new triangle. So if we want to describe where we're translating, you can use this notation here in the subscript. So example, if I did this of triangle ABC, if I wrote that, what that would mean is we're going to translate 1 unit to on the x, to the right, and we're going to translate 3 units up. So it's kind of, again, it's supplying us directions of where to go with the translation T. But of course, you could also write this as x plus a and y plus b. Basically saying, hey, just take your coordinate, add a to the x value, and add b to the y value. Basically just buffing up each of the coordinates based on where we need to move. Okay? So this is our example here. And an example of using the coordinate notation, which I tend to favor a little bit with this, would be something like this, where this would mean that we go 2 to the right and 7 down. Right? So if you had the point 0, 0, under this translation, it would go to 2, negative 7, because it goes right 2, down 7. Make sense? Okay, so this is the same, they're getting across the same idea, but for the translation notation, this is a vector here. This is a vector. It's vector notation, which is basically an arrow. So it's telling us, hey, this arrow that we're drawing, it goes 1 to the right and 3 up. Okay? So anyways, this is a direction, right? It supplies everything we need to know of where we need to slide. Okay? All right. So let's perform some of these translations together. So first, I'm going to just plot the points that they give us. So this, and this, and I'm going to label them as well. And why not connect them? Because it is a triangle after all. Okay? And they want us to graph and label the translation if you move 1 to the right and -4, or let's just say 4 to the left. So I'm going to draw like those red arrows that we saw up in the picture above. So it's going to go, hold on, I think I said left, I meant down. Sorry. Yeah, because the X comes first, right? So 1 to the right, and down 4. So it's kind of like slope that's going on here. 2, 3, 4. So the new point for A prime, is going to be here because we're traveling along that arrow. And you use that arrow to move every single one of these points. So there's another arrow that moves B down to here, and then the last arrow goes down 4, 1, 2, 3, 4, over 1, like that. And the new blue triangle is the image, right? And I should label the other points appropriately like that. So it's really the blue picture is all we really care about. In fact, that's what this is asking us to do down here, is to label all of the vertices from this. And I'm getting these from my picture here. we'll see in a little bit that we don't always need to use the picture. But for me, I'm just grabbing the 3 points that I got when I moved along that red arrow, right? Right 1, down 4, okay? So, but what's kind of nice is you can use the coordinate rule, which if you remember was this, like where we wrote up here. This is coordinate notation, or the coordinate rule. So basically, this is the verbal direction that we're saying. We're saying go right 1, so add 1 to the x, and take away 4 from the y. So for example, this point, -2, 2, it's going to become add 1 and take away, and this is exactly what happened to a and a prime. So the coordinate rule is a nice summary that tells you how to move one point to another. Add 1 to the x part and take away 4 from the y part. All right, let's try this once more. So let me go, and I want to do a little trick here just to help us visually. So when I plot all the points, I'll show you what I'm going to do. So let's see, where's L? L is here. Yep. And then E is here. So I'm going to go ahead and connect the dots. And let's pretend like I labeled them. What my iPad here can do is it can sit here, and it says that we need to go. First, let's digest this here for a second. This means that we need to go left 3 and up 2. So with this technology I have, I can do that by copy and pasting. So I can go 1, 2, 3 to the left, and 1, 2 up. Okay, and we have Nile as our letters, and they go this way, N-I-L-E. And here we have N-I-L-E prime. Okay, so I cheated a little bit, but you just do it point by point. You got to move left 3, up 2, left 3, up 2. You do that for all 4 points, and we get this nice picture here. And then you can read off the vertices from the picture. So N prime is right here. It's going to be -1, -3. I prime is -1, 4. And then we can just, again, just reading them off the picture, we can figure out what the others are this. Okay. What's the coordinate rule? Well, it's the directions we take, but it's written out in math form, right? We take away, we go left of x, and we bulk up y by 2, plus 2. So you don't have to draw a picture, because you could just take every single point and plug it in here and here, and then you'll get this. So again, it's a function. It's plugging in an input and getting an output. Just in this case, the input's the pre-image and the output is the image. Okay, so every little point gets translated the same way. All right, so a little bit more to talk about, and then that'll be it. This one already gives us the nice picture, which is amazing, because then I don't have to draw all of it. So I want to do my little red arrow, because it says that a translation it took the pre-image to the image. So I'm going to go, let's see, from P to P prime, I'm going to go down 2, 1, 2, 3, 4, 5, 6, 7, 8. Down 2, right 8. So translation notation, remember, uses the big T. So X comes first. We want to go 8 in the positive direction, and we want to go down 2. So that is the translation notation that describes this transformation. I think that's good. I mean, you could go full force and write down everything as a input output like this. But the notation is giving us everything we need. This part. So, and as long as we know what the pre-image and image are, we're good. Okay. So this one doesn't give us a picture, but it gives us a input-output pair. The pre-image and the image of point G. Okay, so we're going to try and figure out what we need to change with X and Y so that the translation makes sense. So if we start at 2 with the X coordinate and we go down to -3, that means we took away 5. Okay, and so this is kind of like a -5 arrow. And to go from -8 to -1, we have to add 7. And that kind of makes up the rule. All right. So now, could we use the rule to take H to a point and take I to a point? This would be H prime, this would be I prime. Like that? Well, yeah, of course we can. So if we plug in to here, so we're going to plug in the numbers into here and here. So if X is 2, this coordinate is going to be -3. If Y is 13, this will be 20. So that's H prime. Okay. If X was 10, we'll do 10 minus 5, get 5. And -2 adds 7, and we're going to get 5. So it's a rule. It's something we follow, right? It describes the translation. Take away 5 from the first number and add 7 to the second number. And then we get the location of our points. Okay. Thank you. If you have any questions,